Hope the screen is visible to you people. Is my voice audible? Can I start now? Yeah, thank you so much. Okay, let me um, give a brief overview of what we have discussed last 4 weeks in this NPTEL problem solving session on air pollution and control. Second, give me a second. People are joining still. So, in the first week, we have discussed what is air pollution and what are the impact of air pollution on human health, vegetation, animal, buildings, and all the environment like atmosphere, soil, and water bodies. How it is getting affected, we had seen, right? So, during this problem solving session, also today, we will recall some of the slides if we need. Okay. So, in the second week, we have discussed what are the sources of air pollutant, classification, and transformation of air pollutants like dispersion, diffusion, advection, convection based on the heat transfer. So based on that, how the air pollution is getting disposed, that we have discussed. So based on that only the unstable condition happened, right? Unstable condition is good dispersion condition for the air pollutants. So our aim is to dispose all the air pollutant. Then only it is easy to reduce the ground level concentration, which will have a human health impact. Sir, you have raised your hand. Is there any questions, sir? Mukesh, sir? You can unmute and you can ask. Yeah, okay. Let me continue. If you have any doubt, please post it in the chat box. Today, I can able to answer up to 9 o'clock also. So you can post any number of questions. I can sit and answer because this will be the last session. And third week we have discussed lapse rate. So lapse rate is our change in the temperature with altitude, right? So del T by del Z is our lapse rate. How the temperature is getting increased or decreased based on the height that we have discussed. And based on the lapse rate, we have some plume behavior like looping, coning, fumigation, lofting, inversion condition, that and all we have discussed, right? And based on that, we have a air quality index. Based on monitoring, we have air quality index. Then modeling we did. Based on modeling only, we can identify how much pollutant is going to present in further some distance above or some. I can open some like. Let me open the Swayam portal for you people. You can also go through about the course. Right? Yeah. Lapse rate, plume behavior, and air quality index. Based on that, we have done some modeling, gaseous dispersion modeling for point source, line source, and area source. What are the point source? Some industries chimney are point source. Line source are Whatever the vehicle we are using, that are all line source. What is area source? Dump site or agricultural field or a group of industries like zip code, that are all area sources. So for that we have modelings like Gaussian dispersion model, box model, like that some different modelings we have studied. Then we mention inventories, transportation, agriculture, residential and commercial area, how to find the concentration of pollutant, that is emission inventories, which sector is contributing more, that is source apportionment, that and all we have discussed, right? Based on that, the remote sensing application is advanced technique for the emission inventory, that also we have discussed. Then indoor air pollutant, its source, health impacts, much health impacts is happening due to indoor air pollutant, that also we have discussed. Then finally, global and regional environmental issues. Not only air pollution is not only a local issue, but it's having global impact. That's why global warming, climate action, acid rain, ozone depletion, that and all happened, and what are the treaties and actions rules that was taken globally to mitigate the air pollution. Then air pollution control devices, equipment and design for particulate matter, gases pollutant, that and all we have discussed. Finally, the emerging techniques to mitigate the air pollution, current challenges and forward, like each sector, what are the emerging technologies available, that also we have discussed, right? Then lab based measurement techniques for particulate matter, gaseous pollutants, and handheld samplers and spectrophotometric samplers also we have discussed yesterday as the last week session. Fine. So today we are going to see the week 12 week assignment for this uh, Jan 2025 air pollution control session. Can I go through the material? Please post your answer in the chat box. I will wait for your answers. Every question I will read. Totally we have 120 questions. Okay. So let me go through the questions. If you can't recall, I will also show the answer sheet. That also you can see once. Or if you have any doubt, we can go back to the lecture material and we can clarify it. And I have also uploaded some of the formula sheet points, important points to remember, like some of the year, when it happened, the event, accidents and their year, and treaties and their year and their cause, that and all I have uploaded as a separate PPT in the reading material section. That also you can please go through. And formulas for problem solving also I have uploaded separately. Okay. Yeah. So let me go through the first question. Match the following air pollution event or accident with the respective year. So one out of this, one is very known to us. One is Bhopal gas tragedy, right? When it happened, that is the base for all the air pollution control. Sorry, air pollution act. So Bhopal gas tragedy, when it happened, 1984, right? 1984. So what will be the answer? Bhopal gas tragedy 1984. So C will be matching with 1. So the answer is A. Yeah, that is correct. Please post your answers. That's then you can easily recall the revise the questions, and I think out of this 120 question you can also score a lot of marks. So please try to answer these questions. So Bhopal gas tragedy will be 1984. So C1 you can match this answer. C1 is only here. So A2. And Donora in Pennsylvania, the accident happened in 1948. In Los Angeles, there is a smoke happened, that is in 1954. And finally, vapor cloud explosion in 2009. Okay, so option A is correct. Yeah, that is correct. So you can see here what are the air pollution episodes. So you can see Pennsylvania 1948, Los Angeles 1954, and Bhopal gas tragedy 1984, and vapor cloud explosion 2009. Fine. Yeah. So this also I have uploaded as a separate PPT, only the year that you can go through before going to the exam hall. Yeah. Second question. These are all multiple choice question. Which of the following fuel was banned by King Edward of England in 1307? Is that only coal? Is that only coal? Please check wood, coal, fossil fuel. King Edward in yeah, coal is correct. Yeah, exactly. So here you can see the early 13th century itself they started burning some of the fuels because of the huge impact of the smoke and all. They have banned some fuels like coal. They have burned in 13th century itself. Later only we are starting thinking about ozone depleting substances in 20th century, 21st century. Earlier in 13th century itself they have burned the coal. Okay. Yeah. So the lithosphere includes, we have atmosphere, lithosphere and biosphere. So what is the option here? Crust, uppermost mantle, water over the earth, water beneath the earth. For exams, I don't know. I think 20% or 30% exam questions may be from assignment or related to assignment. So you can once revise your assignment also. That will be having huge part. So please revise your assignment once. That's why I have this revision session today. Yeah. So answer this question. Lithosphere include crust, uppermost mantle, water over the earth, water beneath the earth. So crust will be there, right? And uppermost mantle will be there. Yeah. So 1 and 2. Option C is correct. No. Water over the earth will not be in lithosphere. That will contribute to biosphere. Let me have go to the answer. So answer here is 1 and 2. Crust and uppermost mantle. See here, atmosphere constitutes all the gaseous layer, troposphere, stratosphere, up to exosphere. But hydrogen constitutes the water over and beneath the earth surface. But lithosphere will be only with this solid part, like outer solid part of the earth, crust and uppermost mantle. Where can I find this question? These questions are already what you have answered in the week 1 to week 12. So that I am discussing with the answers. Okay. So old assignment what I have discussed during every week, that also I have uploaded in the uh, weekly PPM or problem solution. I'll just go through for you. So here in your course air pollution and control, after 12th week you can find problem solving session. Go to the problem solving recordings. You will be redirected to a Google sheet. There you can find all the YouTube videos what we have discussed last 12 weeks. And in Google Drive folder you can find lecture material what sir has taught. I have compiled a submerged PDF, and this 12 week what are the problem I have discussed, that I have uploaded, and reading material I have given you some materials for solving the problems, and formulas also I have compiled and given you is the 2-3 single sheets. This itself enough for your revision, and I will also upload one more points to remember PPT that I am preparing now. Okay, this also I will give you. Okay, yeah. So hope I answered your question. Let me move on to this. So, many people have just said like these are all difficult to follow. So I have compiled into week-wise PPT. So I have uploaded here. That will be easy for you to catch. Yeah. Okay. So here answer is lithosphere is only solid part, crust and uppermost mantle. Okay. So fourth question: how can chemical transformation affect air pollutant? By neutralizing them, by forming secondary pollutants, by making them harmless, by increasing their density. Please check how it will be chemical transformation, because many things will happen, like physical transformation will happen that may disperse the pollutant. Chemical transformation will happen that will react with the pollutant and gives different compound. What is that called? Secondary pollutant. Whatever emitting from the source are called primary pollutant. Whatever reacting with other compound by chemical reactions and forming some other compound, that is called secondary pollutant. So by chemical transformation we will get secondary pollutant. So answer is by forming secondary pollutants. Here you can see. So the pollutant may expose to different subject to a range of atmospheric processes. One is by atmospheric emission, transport and mixing, then chemical transformation to form a secondary pollutants. Okay. So fifth question: what are polycyclic aromatic hydrocarbon primarily found in? PAH. Where can we find the PAH? Water and air, coal and tar sediments, vegetation, and natural gas. Aromatic hydrocarbons. So it will have surely aromatic means benzene ring will be there. So answer will be coal and tar sediments. Sure, correct. Yeah. Tar have smell, right? So it will be aromatic hydrocarbons. C hydrocarbons means C and H will be there. So whatever the emission, incomplete combustion of organic matter are found in coal and in tar sediments. Okay, the same carbon monoxide will also come from incomplete combustion of organic matter. Yeah. Let me move on to the next question, which comprises dispersion, transformation, and removal. Source, state of atmosphere, receptor, and response. So this we have discussed. Whenever a pollutant is getting out, that is a source. Then it will be dispersed, transform, and remove. That is state of atmosphere. Finally, it will go for a sink. Emission is source, disposal, deposition is sink. That is receptor response. So these are the three major component of air pollutants. So one is source, final one is sink, center is state of atmosphere. So this dispersion, transformation, and removal will happen at state of atmosphere. Got it? So answer B is correct here. Yeah. So you can see here, source will be the emission, sink will be your impact on the ecosystem or whatever the disposal point. Center one will be dispersion, that is based on the stability, transformation by chemical reactions, removal, maybe settling will happen, scavenging will happen, or absorption may happen into some solid particles or any carbon, biochar or hydrocarbons. Yeah. Seventh question. Which of the following is the short-term effect of dioxin on humans? Short-term effects of dioxin. This is related to the human health effects. Vomiting, coughing, dark spot and lesions on the skin, throat irritation. For dioxins, I am asking. Yeah, this happened to one of the president of, I think, dark spot lesions on the skin. President of? Let me check this. President of Ukraine, yeah, he got the same issue, right? When we discussed about this dioxins. So, President of Ukraine also earlier in 90s they got this dark spot and lesions due to dioxins. Think about the effect, human health effect. Yeah, here you can see. This is a short-term effects. Long-term, it will cause immune, endocrine, and nervous system damage, reproductive infertility, and cancer. Again, a multiple choice question. Which of the following are major contributor of acid rain? So acid rain you may know H2SO4 and HNO3. So whatever multiple choice question, please think and answer. If there is a box, it will be having one or more than one answer. So please think while answering. So this will not give you full mark. So please answer properly. HNO3 and H2SO4. So HNO3 will be from NO2 and H2SO4 will be from SO2. Yeah. So answer C and D are correct. Yeah. Please check your answer, ma'am. So SO2 and NO2 will contribute to acid rain. Not only NO2, NO and NO2 both. So that's why they are calling it NOx. SOx and NOx. Yeah. So whenever they falls on the earth surface, they will affect the earth, the leaves of the plant and also the hydrosphere by affecting the fish. Ninth question. Which of the following pollutant is not mentioned as causing organ toxicity in animals? Some are problematic to animals, right? Causing organ damages, carbon monoxide, nitrous oxide, ammonia, and mercury, which is not causing organ toxicity in animals. Animals organ toxicity means it will contains some. I don't think ammonia, because ammonia may cause, because that will be easily attaching with the organics, even mercury also. No, no. Answer is N2O. Here you can see organ toxicity arising from CFCs and ammonia, volatile organic compounds, mercury, CO, NOx. NOx is NO and NO2, not N2O. Nitrous oxide will not create any problem. NO2 and NO will cause problem. That's why NOx. SOx is a silent killer. Why it's called a silent killer? That will go into the animal body and it will affect the organs in a long term. That's why it's called a silent killer. Okay, all these compounds you can see from the air pollutants causing organ toxicity to the animals. Okay, 10th question. What is the major stressor of stressors to biodiversity caused by air pollution? Excess deposition of airborne nitrogen in the form of ammonia, carbon dioxide emission, ozone layer depletion, acid rain. To the biodiversity they are asking. nitrogen in the form of ammonia, also in the form of HNO3, that is acid rain, right? So both deposition is problematic. One is wet deposition, one is dry deposition. Whenever H2O reacts with nitrogen, then it's called N2O, sorry, NO2 plus H2O will give you HNO3. Fine. So that is one of the problem here. Let me take the pen. So NO2 or NO, both are NOx only, or NOx you can say. If it is depositing as nitrogen, then it is called dry deposition. Whenever it is reacting with water and give you HNO3, that is called a wet deposition. That is depositing as acid rain. And the same like SO2 will react with H2O and give you H2SO4. So that also will deposit as acid rain. Okay. So excess deposition of airborne nitrogen in the form of ammonia is our problem. Here also you can see biodiversity loss. Excess deposition of airborne nitrogen in the form of ammonia is among the main stresses to the biodiversity. Okay. 11th question. As a preservative coating on the building surface, because air pollutants are having major impact on the buildings also. So they are having a preservative coating. Material used will be like acrylic copolymer and siloxane because of their DAS film forming property. Good adhesion, good cohesion, weak cohesion and weak adhesion. What is cohesion? What is adhesion? Adhesion is between two same material. Cohesion is between two different materials. So these are all different. Sorry, I have confused. Cohesion is between two different material. Adhesion is between two different material. Cohesion is between same material. That's why soil we have cohesion. Adhesion we can see from gum and paper. That is adhesive material. Adhesive we will say, right? So gum and paper are different materials. That's why acrylic copolymer and building surface it's called adhesion. Good adhesion property. So B is correct. Yes. So here you can see remedial measures for the buildings and all. You can use any acrylic copolymers or siloxane as a good adhesive film forming property. Then it will not come out from the building and it will not create any pollution. Because whatever the paint we are having, that's what we have discussed in emerging techniques in the air pollution control. They have a good new technology paint that will purify your air. Also, it will not emit any VOC into the air. So both sides it will be beneficial. 11th week we have discussed like emerging technologies, right? Yeah. So 12th question. Forest fire contributes to the presence of PAH in the environment because they involve incomplete combustion of organic matter, complete combustion of trees, chemical reaction in the soil, evaporation of water vapor. So PAH, there are two sources. One is what we have discussed in the third question, and incomplete combustion of organic matter. So both are problem. So here it is again a multiple choice, but only one answer. Found in coal and tar sediments also, its source, the source is also from incomplete combustion of organic matter. Got it? Yeah. So let me go to the second week. If you have any doubt, please unmute and ask. You can also post it in the chat box. Okay. Okay. So second week, why is albedo a significant concern in climatology? What is albedo? Albedo, whenever you are having a black surface, you all know, right? That's why in summer our parents will not allow us to wear black dress. Why? Black dress will absorb a lot. White dress will reflect a lot. That's why black dress, black coating, if any surface is having, that will absorb whatever the sunlight that is hitting on that, and only if it is 100%, only 30% will be reflected. But if it is a white surface, whatever the 100%, 98% will be reflected. Very less absorbing potential. When it is having good albedo. Here it is having very less albedo. Albedo is a reflection property. So albedo is less for black surface. Albedo is high for white surface because it is the reflection property. Yeah, okay. Let me continue. So whenever you are having decrease in the albedo, that is very less albedo, will have increased heat absorption. So only not only the light, heat will also get absorbed in this material, right? So it will create ice melting property. That's why any soot or any black material, carbon, when it is in the atmosphere, that will absorb the light instead of reflecting it. That's why it will help in global warming and reduce the increase the ice melting and increase in the sea level. That are all secondary effects. So decrease in the albedo increases heat absorption, causing ice to melt. Yeah, here you can see high albedo, black surface are having low albedo. It is less reflection property. The material having good reflective property are good for air pollution. Okay. Second one, what happens when soot enters into the atmosphere? What I have mentioned now. Soot means soot if it is the black particles that are all called soots. Particulate matter same with the black particles. So that will reflect or absorb, right? So that will absorb sunlight and generate heat, warming the air. That's called global warming. So that's why soot enters into the atmosphere that will absorb sunlight and generate heat and warm the air particles. Sorry, whole atmosphere. That's the problem with, again, it's a albedo effect. Whenever the sun radiation hits the soot, as temperature rises, ice melts. Again, ice melts means whatever the particle inside the ice will be exposed. Then, like methane may be trapped inside the ice glaciers that will get exposed. Again, it will warm the surface. That's called ice age is formed. And again, we are going with this. Again, another million years. Again, we will get the ice age. Like that, it will be a climate change effect. Yeah. So, how does soot affect snow and ice after being deposited? Again, same question, it seems, related to albedo. Soot will increase the albedo or decrease the albedo. Soot is black particle, so less albedo. So reduce their albedo and absorb more sunlight. Right? So A is correct. Yeah. Please read the question once. Yeah. It reduces their albedo and absorbing more sunlight and generates heat. Okay, fourth question. In water bodies, which gas can be depleted by eutrophication? So what is eutrophication? In a water body, the algae, whenever the BOD is getting increased or any organic matter that is deposited, that need that microorganism need oxygen to eat or to digest this organic matter. So a microorganism will take all the oxygen in the water and it will digest the organic matter. Then the oxygen in the water body will get reduced and already the BOD will also get reduced. Again, the water oxygen will be reduced, so fish cannot have any oxygen to survive. So it will form a condition called eutrophication. So there is a depletion in the oxygen. The property is called eutrophication. Right? So whenever you are washing your cloth nearby any lake or pond, so that will add on BOD to your water. BOD is biochemical oxygen demand, or you can say it's a direct proportional of organic matter, because the soap what you are using, that will have nitrogen and phosphorus, so that will be increased in your water body. So the organic matter, whenever P and K, potassium and phosphorus or nitrogen getting increased, that will add on to the organic load in your water body. So the microorganism requires oxygen to digest your organic matter. It will consume all the oxygen. So oxygen will get depleted. There will be a green formation at the top, algae formation, right? That's called the eutrophication effect. The answer is O2. You can see here the green deposition at the top. Algae will be formed because lots of nutrition. Nutrition, algae will grow good. Which of the following is not a type of marine aerosol? So we have marine aerosols like sea salt is a marine aerosol, sulfate aerosol, mineral dust, methane gas. Yeah, mineral may come from marine, sulfate aerosol may come, sea salt may come, methane gas I don't think it will come from marine. Yeah, sea salt, sulfate aerosol, nitrate aerosol, mineral dust are marine aerosols. Aerosols are small particles emitted from indoor air pollution or outside. So from marine, if it any particles like the sea salt, because at the surface due to temperature rise, the particle may burst and it will form aerosol and it will emit into the atmosphere. So that burst may emit sea salt, sulfate aerosol, nitrate aerosol, and mineral dust, because marine water is salty water, right? So that will contribute to lots of minerals. Yeah. Which is the class? Like he told me now only he sent 5 minutes back. The mail. I didn't check it yet. Yeah, I got the mail. I'll check. There is a live class going on. Yeah. Yeah. Sorry for that. So, what is the approximate size of jet drops compared to their precursor bubble diameter? That's what we know, right? At the surface of the ocean, the bubble may come out as jet drops. So, whatever the bubble size, sorry, jet drop size will be 10% of the bubble size. You can see in the picture. Yeah, here. So due to heat or agitation in the ocean, the bubble may form and it will reach the surface of the ocean and it will burst into jet droplets or film droplets. So that jet droplets will be of 10% of the total bubbles diameter, right? Jet drops produces larger aerosols, roughly around 10% of the precursor bubble dia. Precursor means the older bubble dia. And the film drops will be even more like small mist kind of. I ejected with a wide angular distribution. This is a vertical distribution. Yeah. So again, which is incorrect pair based on the particle size. So based on particle size, we have different uh, terminology, right? Dust, smoke, fumes, mist. So that sheet also I have added here. Dust means 1 to 200 micrometer. Smoke is 0.1 to 1 micrometer. So think about the size. It's in reduced size I have written here. So 1 to 200, 0.01 to 1 micrometer, zero point 0.1 to 1 micrometer, less than 10, less than again 10 with the water droplets, it's fog. And less than 1 micrometer will be aerosol. That's why it's called very small particle. Less than 1 micrometer are called aerosols. Okay, so if you check the answer, mist greater than 1 micrometer is your wrong option. Mist should be less than 10 micrometer. Okay, okay. Gas is the one of the process of movement of gas to transfer heat between regions of different temperature. So, liquid or gas, when it is flowing from one temperature to other, this movement is called convection, advection, diffusion, and dispersion. Once it is related to temperature, then it is called convection. Temperature relation is convection. What is advection? I will tell you all the four definitions. Once it is moving due to difference in the temperature. Here it is 50 degrees Celsius. Here it is 60 degrees Celsius. So whenever there is a temperature lag, the particles are moving. That will be due to the convection property. If it is advection, then bulk movement of liquid. The river is flowing from one end to other. That is called advection due to mechanical things. Dispersion is also purely physical mechanical means like one end to other. That will contribute both advection and diffusion. Dispersion is a whole thing. Okay, what is diffusion? Diffusion is moving from one place to other due to concentration different. Like reverse osmosis, you have seen one side large salt concentration, another side less salt concentration. Or else one side, if I am putting a dye in a glass of water, I am putting one drop of ink, so that will disperse, right, in other parts, because here dye concentration is more, here there is no dye concentration. That movement due to concentration gradient is called diffusion. So due to thermal radiation, then it is called convection. Due to concentration gradient, then it is called this is convection. This is diffusion. Due to bulk movement, then it is called advection. Dispersion is both advection and diffusion, or all the things will be totally called dispersion, right? Yeah, you can see here the question is different temperatures, so convection. Here I am saying this is a fate in the environment. This four are the transport mechanism, pollutant transport mechanism. Air advection, you can say horizontal movement or vertical movement due as a bulk, moving mass of air. Convection is, see, due to solar radiation. Here it is very warm because it's a land. Here it is very cool because it is water surface. So here it is very hot. So air will get heat, and due to density difference, it is going up. Due to here it is a very higher density, it will come here. So this movement or circulation is called convection due to thermal difference in the temperature. And dispersion. Dispersion, as I mentioned, it will constitute a whole mechanical property. Diffusion is movement due to concentration gradient. Here high concentration is low concentration, movement is happening. Okay, hope you understand the transportation mechanisms. Ninth question, what is the primary role of OH radical or hydroxyl radical in the atmosphere? It will control the atmospheric lifetime of gases, absorb UV radiation, causes acid rain, act as a greenhouse gas. So OH radical, we are using as environment engineers, we are using OH radical as a oxidant. Like ozone is one of the oxidant, UV light is one of the oxidant, OH radical is one of the oxidant to kill or to destroy the organic pollutants. Okay, so whenever there is a OH radical in the atmosphere, that will control the atmospheric lifetime of gases, because it will react with the, because this radical is more having a huge energy that can destroy lots of organic matters. That's why we are using advanced oxidation treatment. We are using this OH radicals. So it will control the atmospheric lifetime of gases. See, so OH radical. Radical is the one which will have, instead of electron will be moved and there is a hole formed. So that hole will be waiting for some electrons to react. That's why it will go with any organic matter to destroy. That's a chemical scavenger, we can say. That's why it's called scavenger in that troposphere. Okay. 10th question. Which of the following phenomena is responsible for transferring the heat energy from tropics to the pole? So in the Earth's surface, this is the tropic region or equator, tropic region, and polar regions are here. So the heat is moving from here to here, here to here, and again here to here. This circulation is happening, right? Same tropic to polar, polar to tropic. Same tropic to polar, polar to tropic. So this circulation is due to conduction. Actually, it's heat energy. It should be convection, not conduction. It's a convection. It should be, but it's a bulk movement. So it's called a advection. You can also say it's a conversion due to temperature different, because he transferring the heat. But the movement of, they are not asking about the movement of gas. They are asking about the heat energy transfer. So heat energy is transferred from tropic to polar region. Then it is called the advection. This is a bulk movement. So the answer is advection. You can see here, due to heat flux, the warmer air is moving up and the colder air is moving down. So that you can say as convection. See here, conduction and convection are happening. This energy is then moved to the tropics of the poles by advection. Okay. If it is happening on the Earth's surface, then it is called a conduction or convection. Then the bulk movement is called advection. Hope you are clear about this transportation mechanism. When it is happening on the Earth's surface, as I mentioned, land to water, this is called a convection. But polar region to equator, that's a bulk movement, that is called advection. It's happening here and then moving. This movement is called advection. Okay, yeah, hope you are clear. So we are moving to the third week. So which of the following factor is not associated with the plume property? There are two properties of the air pollutant. One is after emission from the stack, there is a plume property, and also one is stack property. So plume may have some temperature, pressure and all. Stack may have, atmospheric properties, may have some wind speed, pressure, altitude, that are all atmospheric property. So which is plume property, which is atmospheric property? Exit velocity. So plume is exiting. So exit velocity is related to plume. That is correct. Turbulence. So turbulence is due to plume only, because how it is escaping. Atmospheric stability and wind speed. Wind speed is not associated with the plume. It is associated with the atmosphere. So wind speed is one of the answer, and atmospheric stability, C and D, which is not a plume behavior. So C and D is correct. A is not there. So B, C, D. Yeah. So answer is B, C, D. Turbulence is, turbulence is environmental property. Wind speed is environmental property. Atmospheric stability is environmental property. Turbulence is also environmental property, because how the wind is moving the pollutant that is escaped. That is called a turbulence, right? Whenever more turbulence is there, more dispersion will happen. And the plume property, you can say exit velocity, temperature of the plume, and height of release. That is the stack height. These are all related to plume behavior. So the answer is C. B, C, D are wrong option related to plume properties. Yeah. Second question. Which of the following plume type exist under the neutral lapse rate when wind speed is greater than 32 km per hour? There are six plume behaviors. One is looping. Looping will be like this. Fanning. Fanning will be in a straight line. Coning will be like this after emitting from the stack, I am saying. Okay. And then lofting is above the center line, it will be there. That is a loft. The loft is shelf, we will say, right? That is lofting. Fumigation means below the straight line, it will happen. 1, 2, 3, 4, 5. And the last one is inversion. Inversion condition is wherever it is emitting, it will stay there. Straight, it will go. So here they are saying in neutral lapse rate. So neutral lapse rate, wind speed is there. If it is a neutral lapse rate, it will go straight, right? Sorry, it's an inversion condition, it will go straight. In a neutral condition, it will go horizontally straight. So at a 30 km per hour, so it will be forming coning because wind speed is there greater than 32. So it will form a cone. Here you can see. So cone shaped with the horizontal axis because it's actually neutral stability only. But the wind speed is greater than 32 km per hour. Yeah. So third question, during which time is the height of the mixed layer typically the highest? Early morning in the winter, late afternoon in the summer, late evening in the spring, midnight during fall. What is mixed layer? Height of mixed layer. So you can go to the mixed layer here. So there are four layers in the atmosphere. Four layers in the atmosphere. Only surface layer, what we are staying. Then stable boundary layer. Above the stable boundary layer, you can see a residual layer. At both sides of this residual layer, you can find the mixing layers. Okay. So this four you can say as a layers in the atmosphere. Above this, you can find the free atmosphere. So the mixing layer will be higher at the noon. Okay, otherwise you can see like noon there will be more mixing height. Sunset there will be like this residual layer will start forming at the midnight, fully residual layer. Again in the sunrise and noon you can find higher mixing layer. So you can say at the maximum height at noon, maximum height is reached during late afternoon during summer seasons. So the answer is late afternoon in summer. So fourth question is, what causes turbulence in the mixed layer? So we have a mixed layer height. So that will be there is a change in this mixed layer that will be due to turbulence. Which causes this turbulence? Gravitational wave, decreasing atmospheric pressure, ozone formation in the stratosphere, solar heating, and strong winds. So we all know that the why wind is happening first? Yeah, why air is moving? Due to solar radiation. Because of differential heating, there is a movement of air that we are calling as wind. So solar heating and the strong wind are the reason for turbulence in the mixing layer. Okay. If there is no sun, what will happen? The earth will be staying constant and the air will not move anywhere. So that's the problem. Whenever there is a solar radiation, then only it will be having differential heating property, right? That we have discussed in the third week. Yeah. So you can see the turbulence in the mixing layer is due to solar heating and also due to strong wind. Yeah. Fifth question, which of the following is a component of atmospheric boundary layer? So we have four boundary layers, right? One is surface layer, and then stable boundary layer, mixed layer, residual layer. So here the answer only one is stable boundary layer is the only component of atmospheric boundary layer. We have seen a surface layer. We have seen both sides mixing layer. I mean time wise I am saying noon to noon, and then there is a stable boundary layer and a residual layer. Residual layer, stable boundary layer, mixing layer. Here also mixing layer. At noon, mixing layer will be more. At midnight, no mixing layer, only the residual layer and the surface boundary layer will be there. Because at noon, there won't be any turbulence. That's why it's happening like this. Surface layer, mixing layer, residual layer, and stable boundary layer are the components of atmospheric boundary layers, ABL. Above that, there is a free atmosphere. Yeah. Which one of the primary objective of NAMP? NAMP is one of the air quality monitoring program. So what is the aim of that NAMP? determining status and trends of ambient air quality, monitoring biodiversity loss, measuring biodiversity loss, measuring groundwater, studying agricultural productivity. So ours is related only to ambient air quality. So NAMP is to determine status and trends of ambient air quality. Yes. So NAMP was created in 1984 by the CPCB after the Bhopal gas tragedy. They have created 7 stations at Agra and Anpara, and its aim is to determine the status and trends of ambient air quality and identify the non-attainment cities. What is non-attainment city? They have a standard. What are the cities that are not achieving the standard that are called non-attainment cities? Nowadays, number of non-attainment cities are increasing. That's why we have larger monitoring stations, and based on the monitoring results, we are putting penalties to the source people or industries. Okay. Seventh question. What meteorological parameter? What is the meteorological parameter? That is atmospheric parameter or integrated with the air quality monitoring under NAMP. Wind speed, wind direction, relative humidity and temperature. Yeah, that's correct. NAMP is related with all these meteorological parameters. You can see under NAMP, these are all the pollutants you can find. SO2, NO2, PM, fine particulate matter, suspended particulate matter, and PM10 is called what? It can go into your nose. That's why it's called respirable suspended particulate matter. It's RSPM. Then PM, that's our PM10. Then fine particulate matter are called PM2.5 that can enter into your bronchs. So meteorological parameters are considered in the NAMP like wind speed, wind direction, relative humidity and temperature. So eighth question, which of the following is not an outcome of eclipsing in air quality indices? What is air quality indexes? AQI, air quality indices are a number. It's a single number that will be formed from different pollutants. I have to consider PM, SO2, NO2, ozone, lead, all this concentration we can find for a, if I am finding AQI for NIT, I will measure all those pollutants. And I have the standards. What is the standard? National Ambient Air Quality Standards, NOx, right? NAAQS. So if I know the concentration in NIT, if I know the NOx standards like 20, 60, 80, I know, right? So I have to divide both and how much excess it's having, that will be added or a weighted average I have to take, that will give you a single number that is called the AQI. So that will be 50 to 100, 0 to 50, 100 to 150 based on good, medium, very low or very high. That will be related to your health impacts. So there will be some errors in the AQI. That is called eclipsing. Another one is ambiguity. So eclipsing is the one which will, what do you know eclipse, right? Moon or eclipse, solar eclipse. So that will hide some. So it is underestimated, not overestimated. B is wrong, C is correct because it's hiding some. So what is solar eclipse? That will hide, right? So the some value it have hidden, so it's underestimation. It's called eclipsing. Then what is ambiguity? You can see here. Eclipsing occurs when the air pollution indices does not indicate poor air quality. There is a poor air quality, but I am saying that is a good. So I am covering some. That's called the eclipsing error, underestimation of the pollutants. What show ambiguity? That is a overestimation due to minor deviation in the single pollutant. Because if there is a PM only higher, other pollutants are very low, but my AQI will be very high due to PM. So that is the ambiguity, right? So that is the overestimation of AQI. Overestimation due to minor deviation, that is ambiguity. Please be remember with eclipsing and ambiguity, that are the errors in the AQI. Ambiguity when occurs on air pollution indices gives a false alarm even though concentrations are within the limit. Earlier it was poor quality, but I am saying as good. But here I am saying bad, but all the air qualities are within the permissible limit. So it's overestimation of air quality. Okay. So 10th question, which of the following is considered a key component in modeling parameters for air quality? Air quality, which is the key parameter, soil composition, emission source, traffic pattern, only population density. I want to know where it is going to emit. So emission source play a key role. So answer is emission source. Correct? Yeah. Yeah, these are all the basic components of air quality modeling. Emission source, receptor location where it is going to, where we are going to measure, that is the point of interest. Metrology, initial concentration, total concentration, estimated concentration, air chemistry, removal process. That is sinking, where it is going to deposit, right? These are all key components of air quality modeling. Yeah. Moving on to the fifth week, we have discussed the lapse rate and all. So for mean wind speed at the plume height, so we have a chimney, and we know the wind speed at a 10-meter height or my floor level. What is the wind speed? I know, but after 100 meter, what is the wind speed? I don't know, right? So if I know the wind speed at zero height, if I know the height of the chimney, that is the Z. If I want to know the wind speed at the height Z, then I can use the formula U Z equal to U naught into, which is correct. I know the altitude and whatever the height I have measured. 10 meter means Z naught. Z naught by Z power P. What is P? Stability condition. If it is unstable condition, then wind speed will be more. If it is a stable condition, then wind speed will be similar, nearly similar. With the height, the wind speed will increase. That's the concept. This is the wind speed, this is the height. If you increase the height, wind speed will also increase. That is a general thing. What is the formula? U is equal to U naught into, which is correct. Power P should be there. So P, B or D, which is correct. D. No, B. Z not by Z. Z not by Z power P. Please check your answers. Oh. My mistake. Yeah. Z by Z not. Yeah. It's wrong. This is correct answer. Answer option D is correct answer. Okay. Yeah. Sorry for the confusion. Z by Z not into Z not power P. U of Z equal to U naught into Z by Z not power P. Right to that D. Yeah. So correct. Yeah. Z by Z not power P. P is your stability condition factor. So P you can find from what is the P usually will be 0.7, 0.8 based on the stability condition. It's a stable, unstable, inversion, like that you can find the P. A, B, C, D stability conditions. Okay. Okay. Question number 2 of fifth week. How does the wind angle direction with respect to the receptor affect the total concentration of the air pollutant? It will not remain constant anyway. It will not remain constant. Wind angle direction. So wind angle is there, wind direction is there. How it will affect? If the wind angle increases, the total concentration of the pollution increases with increases in the wind angle, decreases with increase in the wind angle. If I am emitting from a source here, okay, it's going. I am a receptor here. If the wind angle is more, it's going this way. Then my concentration here will be lesser, right? So decrease with the wind angle increases. That's what correct. So that's what we have discussed here. If the wind angle gets increased, my concentration will be reduced. The total concentration of the air decreases when the wind angle increases. So option C is correct. Yes. That's the wind direction and wind angle matters. Okay, here there is a formula from Gaussian dispersion model to find the concentration of pollutant. If you know all the flow rate, sigma Z and sigma Y as standard unit of standard deviation equation. What is the unit of sigma Z? They are asking. Meter per second, gram per meter, or microgram per meter. How to find sigma Z and sigma Y? From, if you know the x is meters, x in meters, sigma Y or sigma Z from the graph. Graph will be A condition, B condition, C condition, D condition. This will be in log, semi-log sheet, right? 0 meter, 100 meter, 1000 meter, 10,000 meters. Like that, it will be in semi-log. This will be in 5, 10, 15, 20, 25, 30. So, normal graph. So, if I know 1000 meters, then I know if it is a C stability class, then I can find my sigma Z or sigma Y. What is the unit? Sigma Y and sigma Z are in meters. or some formulas also there to find sigma and sigma z if you know the stability class and the x value. So answer is meters. Here you can see concentration will be in gram per meter cube or microgram per meter cube, anything you can use. Emission will be gram per second from this chimney. How much pollutant is emitting, that is gram per second. Then I know after 1000 meter what is the gram per meter cube concentration, right? So x distance is in meters. Where is x distance? Cross wind distance or downwind distance is your x. Cross wind distance is your y. Z will be your altitude height. At what height? Effective height of the it's a effective height. What is effective height? Physical stack height plus plume rise. So this small h plus del h will give you the total h, right? That is the effective stack height. That is also in meter. Physical stack height is in meter. Sigma and sigma z will be in meter. That are all constants. Okay. So you all know about the Gaussian plume model, I guess. And the initial spread of the interpretation of the area source is given us. So area source. If I know the area source, if I know the pollution, then I am fixing an area. What is the surface of this area? I am assuming an area. If I know S of this area, and the sigma y can easily be found with S by 4.2, right? It's simple formula. Whatever the Gaussian model we have discussed is for plume. For area, we know the S and we can find the sigma y naught by S by 4.2. That's the formula. Sigma y we can find if I know the S, because it's emitting from this area and I am virtually taking a point. That's a virtual point source. Then I know the receptor. So from the center of the emission, I can't take x. That's I have to get an imaginary point. From that x naught is there. The total x will be considered, right? X naught plus xr will be considered as x for my area source. So that calculation also we have discussed. So yes, we know. Then sigma y is the initial spread we can find by s by 4.2. Yeah, so that is a standard value. Okay, another question. On a highway, lot of vehicles are traveling, daily release chemical emission. Okay, average emission rate is given. So gram per second is your Q. Q is given. Okay, determine the total chemical concentration. See, they are asking at a 0.6 meter downwind. So after 600 meters, so 0.6 kilometer or 600 meters, that is your x. Okay, and then highway on overcast day. Overcast day is you know the dispersion condition, stability condition, that is usually it will be in C or D class. So you can also find that. And wind speed U is given as 5 meter per second. Number of vehicles per unit length is 0.8 per meter. So you can know the formula. What is the formula for finding? It's a vehicle. So line source, right? Line source, the concentration is 2q by root of 2 pi sigma z y. So q you know, u you know, sigma z can be found from the graph. You know the x, that is 600 meters. So how to find 600? This is 1, this is 10, this is 100. So it's in kilometers. So 0.6. 0.6 at the stability class. Overcast day is D stability. So D if you go, so you can find sigma z. Sigma z as 50. So that you can easily found. This is 50 class. Okay. Yeah. So if you substitute 50 for sigma z and u, you all know. Data. Can I check the data once? 0.6 meter they have taken correct only here. Yeah. 0.18 is the number of vehicles. So yeah, you have to find gram per second, but we have to put the q in terms of gram per second meter because it's a line source. So we have to multiply with 0.18, that is also given. Into 0.05 is your pollutant emission rate. You will get 9 into 10 power minus 3 is given. 2 is correct. 50 is correct. U is 5. Yeah, everything is correct. Can I check with the calculator once? 1 second. Let me check. 2 into 9 into e minus 3 divided by 50 divided by 5 divided by root of 2 pi. It's coming 2.8 into 10 power minus, okay, 28.8 into 10 power minus 6 is correct only. Because they are asking 500 meters 0, 0. So sigma y will not come. It's correct only, ma'am. You have any doubt in this? In doubt session, sir or ma'am was said that the data is not correct. Oh, mm, yeah, everything is correct only. So ground level, so h equal to 0. So all these components become 1. There is no problem in the question. I think in the next session I have clarified with this solution book, right? No. Um, so still you have any confusion here after this? I think the question is clear now. Mm. We have solved this, right? 6.6 kilometer we have taken 1, 2, 3, 4, 5, 6. So 0.6 into D 1 to 50. It's correct actually. The answers are correct. The data is correct. Yeah. Can you go through? Sixth question. What does assimilation capacity of the air environment refer to? Yeah. Thank you. So assimilation capacity. So we have an area. So if I know Trichy is a city, I have already 100 industries emitting source. If another one industry is going to come, so they are asking me for approval as a pollution control board, as state pollution or central pollution control board, based on the capacity of the industry or capacity of production. They are asking for the approval. Okay, I have to know what is the already emission from this 100 industries from and I have to know what is the assimilation capacity of the Trichy's air quality. So if it is already having reached this assimilation capacity, I should not give consent to this industry. If if I can pollute some more, then I can give. It's not pollution. It's like emission or the air can able to handle the dispersion. Then I can give approval to this industry, right? So that's called assimilative capacity. So the amount of pollutant that can be discharged without violating the not water standards, without violating air quality standards. So the maximum amount of pollution that can be discharged, that is 100 industry or 101 industry, without violating the air quality standards. So already all the industries are emitting. Still my PM is 10 microgram per meter cube. But my standard allows I can pollute up to 2 or 20 microgram per meter cube. So I can give approval to the industry, right? You got it? So that I can also get 12 or 13 microgram per meter cube. Still my air quality is within the limit of 20. That is the standard. So simulation capacity is the maximum amount of pollution that can be discharged without violating the air quality standards. Yeah. Not only the industries, vehicular emission, methane emission from the cattle, household emissions, volcanic emissions if it is a volcanic prone zones. So that are all need to be discussed. Okay. What does a higher ventilation coefficient indicate? Ventilation coefficient. So if there is good ventilation, poor air quality, inefficient dispersal of pollution, efficient atmospheric dispersion, and better air quality, increased level of hazardous pollution. So one is looking good. Higher ventilation coefficient. Higher ventilation means efficient atmospheric dispersion. That is correct, right? So good. That's why we have to have lots of ventilation windows in our home. When good ventilation, less dispersion of high dispersion of pollution. And one more problem with the ventilation in the indoor air pollution is if you have more indoor, so more windows, then outside air pollution may also get inside. That is one of the problem. But dispersion of pollution is surely will happen. Efficient atmospheric dispersion will happen. Higher the coefficient, more efficient the atmospheric able to disperse and dispose. Lower ventilation coefficient, poor disposal of pollutant, causing stagnation. If it's a closed building or a closed environment, then it will be stagnation of pollutant within there, right? Yeah. Then, eighth question. The height of the layer in which the air pollutant or any constituent emitted or entrained into it is vertically disposed due to turbulence and convection, it's called. So, we have already discussed whatever the pollution is emitting, that will reach up to a height, right? And then it will constitute emitted or entrained into it, vertically disposed due to turbulence and convection. It will get disposed. So, after that, it will not go. What height is called this? A mixing height, right? Here you can see. So there is a height up to which the pollutant will be disposed due to the turbulence and convection. Convection is what? Heat difference. What is called turbulence? Due to a movement of wind or wind speed and velocity, it may get disposed. So up to a height, it will get disposed. That's called mixing depth or mixing height. What is the emission factor? Emission factor. That's a single formula. EF equal to mass of the pollutant divided by volume of raw material. That's called the emission factor. So as a mass of pollutant divided by volume of weight of raw material. That's called the emission factor. Yeah. B is correct. What does a gridded emission inventory provide? There are four different emission inventories. One is called the gridded emission inventory. What is gridded emission inventory will do? What we will get? What are grids? So if it is an India map, I'm sorry for this, and then you can divide it into different grids. So each grid you can have a color coding. If you take Tamil Nadu alone, so Tamil Nadu I can split into different grids, and I have one grid will be 1 kilometer per 1 kilometer square. So that will have a color coding. Like that, if I have a color coding, that will be having in location information, also the emission of air pollutant and their sources. So all that will be in the gridded emission data inventory. Emission inventory is one of the data collected data representation format. So annual average method we can mention, seasonal inventory we can do, forecast and future emission we can do, gridded and modeled inventory we can do. So if it is an annual average, you can see every year how it is increasing. This is called the annual average inventory. If it is season, spring, summer and autumn, winter, how it is varying. If it is forecasted or future projection, then also you can know how it is forecasted in future, like 2030, 2050, how much you want to get based on the Paris Agreement, how can we project like that and all. You can do that is forecasted or future projection. It is a gridded emission inventory. You can see here, any location can be gridded with this and coded with the colors. So you can see high polluted area, low polluted area, that and all you can easily identify. So emission inventory based on mapping point locations and you know the emission source also. So moving on to the sixth week. So which of the following limitation are not associated with the EMPA model? So one of the model for emission inventory for estimating vehicular emission. Inclusion of catalytic model should lead to improvement in existing model. It has been developed only for light duty vehicle. Include the dynamic behavior of the engine. So EMPA model does not include the dynamic behavior of the engine. So option C is not associated with EMPA. So C is correct, I guess. Yeah. You can see it does not include the dynamic behavior. Catalytic model need to be included, lead to improvement in the existing model, and it's only developed for light duty vehicles. So option C is correct. Only third one. It does not include dynamic behavior of the engine. EMPA model. WAPI model. WAPI model we all know, vehicular air pollution inventory. That is developed for developing countries like India. So that consider different air pollutant. Which air pollutant is not considered in WAPI model? CO, CO2, PM and ozone. WAPI model considers basic pollutants like PM, CO2, CO, nitrates, nitrite and all. So WAPI model specially designed for developing countries like India, incorporated climate correction factors because other models don't have any climatic corrections, right? But India we have a different climatic condition that also incorporated in this and simple to use and use in public domain. So carbon monoxide, carbon dioxide, PM, HC, NOx, benzene and all other PAH acetylene are considered. Ozone is not considered in WAPI model. So the answer is D. Yeah. Can you move on to the next? Another one is running exhaust emission. We can find running loss evaporative emissions. These are all for vehicles, right? Non-exhaust emission like brake and tires also, PM10 and 2.5 also. All these three can be found from WAPI model. Yes. The third question: what is the primary purpose of Markle model? Market allocation. Market allocation means that will be based on economic growth only, right? Because it's a market, there is a business, there is economic growth. So market location model, that is a Markle model. That's primary purpose is to assess the economic growth of the developing countries. So option A is correct. I'm sorry. It's allocation. You can see developed in a cooperative multinational project for a compliance with the UN Framework Convention on Climate Change. Yeah, it should. That's why I thought why it should need to find the economic growth. It's related to air pollution, right? Yeah, to model energy system and compliance with the climate change agreements. That's why Cull model was developed. Please be conscious, don't do this type of mistakes. Yeah, and it interconnects the conversion and consumption of energy, like primary supplies, conversion process, end use demand of the energy services. Based on that, it will relate to the climate action networks. Then primary focus of gains model. Gains model. Gains model is related to GHG emissions, right? Yeah. So it's estimating cost and potential for air pollution and control and GHG emissions. GAINS is greenhouse, full name itself, a greenhouse gas and air pollution interaction and the synergies model. So GAINS, grown out to RAINS. RAINS is again regional air pollution information model. They were developing this, and it is integrated assessment tool for dealing with the cost and the potential for air pollution control and greenhouse gas mitigation. Yes. Fifth one will be, which of the following pollutants is primarily emitted from livestock enteric fermentation? All know livestock are cattle. So cattle like cow may have a rectum with the 4 compartments. So the food will be digested here and stored and digested here like anaerobic digester, and it will emit CH4, because any fermentation or anaerobic digestion will produce CH4. If it is aerobic digestion, CO2 will be released. But this will release biogas. That's why gobar gas we are developing, right? So from cow dung, if it is putting it to the anaerobic digester, you can get gobar gas. So that will constitute mostly 60% to 80% methane and 20% your CO2. Uh, Sorry, anything you want to ask? Okay, let me continue. So, enteric fermentation is inside the rectum of the cattle or livestock, and rice cultivation. This both are related to agricultural activities. So, rice cultivation will also produce mostly the methane gas. So, answer A is correct. Methane. Okay. So, this is from agricultural emission. So, we have discussed the vehicular emission, agricultural emission, industrial emission, residential and commercial emission in this 6th week. So, out of agricultural emission, we know from the enteric fermentation of livestock and from the uh, um, rice cultivation, because paddy cultivation will also contribute lots of methane emission. That is also one of the climate impact. Okay, so you have to think methane is one of the from enteric fermentation, rice production, burning of greenhouse gases. Sixth question: what source contributes to the release of volatile organic matter in the agriculture? Same, agriculture is the sector. Which source contributes to VOCs? Metabolic process of vegetation and livestock, fertilization of soil, diesel engines in the machineries. Because diesel is a hydrocarbon, so surely it will release VOC. So option C is correct. Okay. Filtration in the soil. Fertilizers will be organics only, but that will not emit lots of VOCs. So B is not correct. Metabolic process of vegetation and livestock. Because vegetation after metabolism, yeah, surely it will release VOC. So both A and C are correct. So A, this one you can see here. So any metabolism will also release VOC, and engines will also release VOC, MMVOCs, right? So you can see here VOC are from metabolic process of vegetation, manure, burning of agricultural residues, and agricultural machineries, whatever the diesel-based vehicles or petrol-based vehicles. Okay, yeah, option D is correct. Both A and C. Here, seventh question. What activities are covered under the residential sector in relation to fuel consumption? So in residential sector, not in agricultural, in residential sector, we are consuming fuel for what? In home. Residential means home or commercial parts in like hotels and all. So we are using heatings, boiler operation, and commercial. No, this is commercial. Residential, domestic cooking, use of fireplaces. That's correct. Capacity production, power generation, that is in offices. Waste management, recycling also, it's a municipality sector. So only in the residential if using domestic cooking and use of fireplaces like for heating purpose. So option B is correct. Please post your answers in the chat box. I want to know like people are following here. This will be helpful for your revision. So please follow up. Yeah. So residential sector, household including domestic cooking and use of fireplaces will emit that will be the source for your air pollutants. Eighth question. Which of the following facilities are commonly found in urban areas, contributing to commercial sector emission? For commercial sectors, what will be considered as commercial? Agricultural field is not commercial. Yeah. Rural community, they are asking about urban areas, so rural community will not be there. Schools and public park are institutions, so that will not be there. So commercial will be hospitals, shopping malls, and crematoriums. So that will contribute to the emissions in the commercial sector. You can see cooking, heating, boiler operation in captivity in the commercial sector such as hotels, offices, restaurants, shopping malls, and crematoriums, hospitals, and all. Okay. Which component is used to detect CO, CO2? Yesterday also we have discussed the same, right? HC. So all are having carbon. So which is used to measure carbon? Which is used to measure carbon? NDIR sensors, non-dispersive infrared. NDIR sensors. That's what we discussed yesterday also, right? So all carbon can be measured with the NDIR. So CO2 in the handheld sampler we have measured with the NDIR. CO we have measured with the electrochemical based sensors. Electrochemical based sensors. Then temperature we have measured with the thermocouples platinum electrodes. Then relative humidity we have measured in percentage with a thin film that can have different dipoles or a dielectric constant and reacting with this moisture in the atmosphere. It is relative humidity. And also it will give dew point. So with the 4 electrodes or sensors, we are measuring 5 parameters of atmosphere. That is in the handheld samplers we have discussed, right? Some small monitors in the hand. So NDAR is used to measure carbon. So HC also we can measure with NDAR. Yeah. Non-dispersive infrared components used to measure detect CO, CO2 and HC. Yeah. So what is the primary purpose of aerosol optical depth? What is AOD? Aerosol optical depth. That's optical in the sense it will be due to light only, right? So it's a quantity of light removed by the aerosol in the atmosphere. So all the names will be covered here. So how much quantity of light removed by the aerosol? Because whatever the light that is coming into the Earth's surface, whenever there is a aerosol particles, as I mentioned, the aerosol will reflect the light because it's a turbidity. Whenever you are putting some soil in the water in the beaker, so whatever the light you pass, that will not come out in the other end. That will get refracted or reflected by the soil particles. Same, it's a water as a fluid, air as a fluid here in the atmosphere. Whenever aerosol particles are there, light will come and it will get reflected. Heat, if it is a property, then it is called albedo. Light, then it is called aerosol optical depth. How much quantity of light that is removed by the aerosols in the atmosphere is called aerosol optical depth. So quantity of light removed from a beam by scattering of absorption by aerosol during its path through the atmosphere. You can see here. That's why after rain we can find a pure vision or a clarity image. If it is not raining for long period, then you cannot see any. If you go to Taj Mahal or any scenery after rain, it will looks like beautiful. Like any mountain after rain, you can see it's a beautiful vision because there is no aerosol in the atmosphere that is already got deposited. So there is no aerosol optical depth. So that's expressed as a quantity of light removed by the scattering of or absorption of aerosol due to its path through the atmosphere. Okay. So moving to the 7th week. Okay. Let me somewhat speed up because the time is already 7:30. Let me speed up. Please post the answer in the chat box. EPA AP 42 2000 used for emission calculation. What is EPA? They are asking. It's a modeling wind speed. It's measuring the concentration of the gaseous pollutant and providing emission factor for the pollutant not listed elsewhere and determining the thermal efficiency of the fuel. EPA is used to measure emission factor for pollutant not listed elsewhere. That's why EPA is what we say like a catalog. That's a list of pollutant having the emission factor that is used to find the health risk and all. Okay, so you can see providing emission factor for pollutant not listed elsewhere. That's the EPA was given by Environmental Protection Agency. Yeah, say AP 42 2000 and adopted by CPCB. Where is a curb site location typically found? Curb site. In solid waste also we will say curbside collection. That is at the alley side, alongside the pavement. Yeah. So on the way alongside the pavement, we will keep the dustbins. That's called the alley collection or curbside collection. Sorry, alley is at the end. Curbside collection is at the pavement, alongside the pavement. So you can see traffic survey they have to do at the uh, curb side. Like see, uh, here curb side location nearest to 12 hours monitoring they have to do. Like at the pavement they are sitting and doing. Yes. One second. Yeah. Third question. What is the primary goal of bottom up or source based method? There are two methods. One is top down and bottom up method for air quality measurement. Bottom up is called source based method because from the source how much it is emitting, and from that we are finding the concentration of pollutant at the receptor side. The other one is top down. I am having this much pollution here. Then what is the source? So that is top to bottom. Uh, Top down method. That is receptor based method. This is source based method. From the source I am going. That is bottom up approach. So bottom up approach, what is the primary goal? To locate pollution source and develop emission inventories. Because it's going from the source, that's why it's the emission inventory we are doing from the pollution source. So to locate a pollution source and develop an emission inventory, that is called bottom up. Top down is wherever I am getting the concentration this much, I am getting in N83 it is now 20 microgram per meter cube PM. Then what will be the source for this nearby Sipcot or what? So that I am going from bottom to top. Sorry, top to down, bottom. Yeah. So in the mass balance equation given below, Xij represent. Xij is here. What is this? It's a concentration only, right? It's a concentration of jth species in the ith sample. Yeah. Jth species in the ith sample. Chemical mass balance, CMD model. And which of the following pollutant or receptor model mainly used to analysis? Pollutants or receptor model. Receptor is whatever I am getting at the end, receptor end, sink end. So which pollutant can be considered? Particulate matter. Because others are chemically reactive. Particulate matters are not chemically reactive because it's solid, right? It's a particulate matter, particle. So that will not react. So whatever emitted, that will reach the receptor after dispersion. So I am emitting 100 gram per second or 100 gram per meter cube here as a Q or as a emission rate I am saying. And at the after 1 kilometer, I am getting 10 gram per meter cube as a concentration. So PM is a mass balance. Other 90 will go somewhere else. It will not react with the atmosphere. But if you take ozone, if it is released 100 microgram here, and if I am getting 10 here, 90 will get chemically reacted on the way. But particulate matter will not be chemically reactive. So I can choose particulate matter as a receptor model. Well, sorry, for receptor model, I can choose particulate matter as a good pollutant. Okay, here you can say. It should not have any, because it's a top down. From the pollutant I am going to find the source, so it should not be reactive pollutant. May differentiate chemical composition of the PM. That's why it's the primary and secondary contributor. I can use that. But visual test is commonly used to assess the normality of data. Normal probability plots, pie charts, line graph, bar chart. For normality we need to know normal probability graph, like a bell chart curve we need, or it's a box whisker model. If I want a normal probability plot, I need to have a, sorry, for a normality, I have to have a normal probability plots. And what is common myth about air pollution? This is around about indoor air pollution. Air pollution occurs only outdoor. Air pollution occurs indoor and outdoor equally. Air pollution is harmless. Air pollution is caused by poor air quality only, which is correct. No, A is not correct. Air pollution occurs only outdoor. We have studied a lot about indoor, right? Air pollution is harmless is also wrong. Air pollution is caused by pure air quality only. That is also wrong. So air pollution occurs indoor and outdoor equally. Or Okay, sorry. They are asking what is the myth. What is the myth? I'm sorry. So the myth is air pollution occurs only outdoor is the myth. It's a false statement. Yeah. So answer is A. Air pollution occurs only outdoor is a myth. Right? Yeah. Air pollution occurs only outdoor is a myth. The truth is air inside the conditional space can actually more polluted than the outdoor air. Yeah, because it's a confined space. So there is a stagnant of air pollution. There is no ventilation. So there will be more pollution in indoor compared to outdoor because it's having good dispersion outdoor. Yeah. Eighth question. Which of the following is not a cause of indoor air pollutant? Indoor air I am talking about. Air tightness of building, which is not a cause. So poorly designed air conditioning system, high altitude, indoor source of pollution. So due to tightness, there is a stagnation. So that is correct only. Poor designed air conditioning system. There is no ventilation. That is also correct. Indoor source of pollution. If I am cooking inside, I am burning anything inside. That is one of the indoor air source. That is also correct. This is not a source. High altitude is not a source because based on the height, I don't have any impact on the indoor air quality. But outdoor air quality, it will vary with the height, right? Right. So answer C is correct. Air tightness, poorly designed indoor source of pollution. Outdoor source of pollution is also one of the source for indoor air pollution. So if they give this option, that is also correct. Outdoor source may also come inside and create indoor air pollution. Yeah. So ninth question: how does excess oxygen affect the formation of carbon monoxide? So if I am burning a fossil fuel or any wood with the full of oxygen, then I will get CO2. If I am having partial oxygen or 50% only, I'll get CO. So if I am having excess oxygen, CO will be reduced because CO, the source is incomplete combustion of organic matter or any fuel, or incomplete combustion is the major source. So if it is a complete combustion with excess oxygen, there is decrease in the CO formation. Understand? Yeah. Carbon monoxide, the source is lack of oxygen or due to low mixing or incomplete combustion. Yeah. 10th question. What are the levels of lead in soil typically higher? Where are the levels of lead in soil typically higher? Near schools and playground, near such as lead smelters, mines. So we all know, near the lead smelters, mines, and heavily trafficked road, because leaded petrol was there earlier. So nearly the heavily trafficked region also, due to leaded petrol, the lead concentration in the soil may be higher. So answer option B is correct. Here you can see level of lead is higher near sources such as lead smelters, mines, old agricultural field, and heavily trafficked roads. So again, we are moving to eighth week. Yeah. So what are the immediate health effect of exposure to indoor air pollutants? Immediate health effect: respiratory disease and cancer. That is a long-term effect. Irritation of eyes and nose. Cardiovascular is also long-term effect. Neurology is also long-term effect. Irritation in the eye, nose, and throat. So try to get from the options also. Please delete the option, then you find a correct option. That is also good way of answering. Okay, if you don't know the answer. Yeah. So option is irritation, the eyes, nose, and throat are an immediate effect, short-term effect. Asbestos, the name itself mentions, asbestos is a serious long-term non-cancerous disease of the lungs associated with the exposure of asbestos, because asbestos causes asbestosis. Nowadays, asbestos are banned. Asbestos sheet earlier we are using for as a building material. Now it's banned in India because it's having small fiber, that is a solid material that will come out as a pollutant in the air, that will also have lungs effect. It's a non-cancerous disease, but it will affect the lungs a lot, causing asthma and all. That's the health effects of asbestos, lung cancer, mesothelioma, that is the thin lining of lungs, and asbestos, a serious progressive long-term and non-cancerous disease of the lungs. Okay. What is the primary goal of exposure assessment for indoor air pollutants? Why we need to assess the indoor air pollutant? What is the primary goal? To enhance the building aesthetic, to identify the pollutant source and quantity risk, to promote the use of natural ventilation, calculate the construction cost. No. Based on this two, which is correct? To identify the pollution source and quantify the risk. That is correct. Yeah. Because we need outdoor air pollution assessment also. The goal is to identify the source. Same for the indoor also. If you are doing every parts of your building, then you know which part is contributing or what is the source of your pollutant. Okay. Yeah. So relationship between the indoor and outdoor airborne exposure, and the main aim is to understand the exposure and the health impacts and the source identification. Yeah. Which type of sampling relies on the kinetic energy of the gas molecule and diffusion of the gas in a enclosed space on a sorbent medium. There are different sampling, active, passive, stratified, and cluster sampling. They are defining one sampling method release on a kinetic energy of the gas molecules because and diffusion of the gas in a enclosed space. What it is called passive. Here you can see active sampling requires the use of pumping device, but passive sampling only relies on the kinetic energy. It will move on its own. It will diffuse without any pumping mechanism. That's why it's active requires pump, passive requires no pump. In landfill also we have active bioreactor landfills and passive bioreactor landfills. We have a gas collection system and recirculation. If the gas is going collected with the pump, then it is called active. The gas is coming out on its own kinetic energy. Landfill gas, you know, right? It's anaerobic digestion, gas will be produced. So that biogas, if it is coming out on its own due to kinetic energy, then it is called passive sampling. Okay, yeah. Same here for sampling also, we are doing the same method. Which method is commonly used in a computational fluid mechanics, CFD modeling? Finite element method, box modeling, well mixed modeling, and stratified modeling. Computational fluid is used in the box mode. It's a okay. It's a computational based. It's a finite element method. Yeah, yeah. Based on the finite element, you can find it's a fluid, right? Gas is considered as a fluid, so the movement of fluid can be designed or coded with the CFDs. Which modeling approach assumes spatially uniform pollutant concentration indoors? Spatially uniform concentration. If you want to get a uniform concentration in water also, you need to have a stirrer. Then only whatever the water you are having, that will have equal concentration everywhere. So if you mix it well, you will have a uniform concentration. Otherwise, whatever the pollutant coming in, that will be staying there itself. If you are mixing well, then well mixed model will give you uniform pollutant concentration indoors. Yeah. Well mixed model and partially mixed ventilation model are the two concepts we are using. What is the primary advantage of HEPA filters? That's one of the filter used for air cleaning in the indoors. So what is the advantage of that? They remove both gaseous and particulate matter. They are cost effective. They effectively capture fine and ultra fine particles. They eliminate microbial contamination. HEPA is for fine particulate or microbial concentration. Yeah, fine and ultra fine particles HEPA will be used. So you can see it's a fine frame having filter sheets. So that's used to remove fines and ultra fine particles. Right? Yeah. Which technology is most effective in reducing microbial contamination in the indoor air? Microbial contamination can be removed with the UVGI system, ionizer, activated carbon filters, cyclone separators. Uh, I couldn't understand your question, sir. In week 9, what is your problem? Like question match nahi kar raha hai, problem solution PDFs. Like it's matching, I guess. I will show in the next. We are in the 8th week. Next week we'll go and we'll check whether it's matching or not. Let me check. Yeah. So microbial concentration. We are having UVGI system, right? Because the name itself, ultraviolet germicidal irradiation, germ, it's a microbial form. So UV, as I mentioned, UV, OH radical, or you can use as a microbial, what do we say, microbial disinfectors. So ultraviolet germicidal irradiation, UVGI is a air cleanser used for removing viable airborne microorganisms. Yeah. So it can remove up to 99%. It's a surface disinfectant. According to case study that we have discussed, which method is used to measure personal exposure of PM 2.5? High volume sampler? No, that is for PM 10. Palm sized optical sensors, passive diffusion tubes, infrared imaging. So in that case study, what we have discussed, they have used a palm sized optical sensors. They have given to large number of population, and every day they have hanging that in their neck, and they have measured wherever they are going. Right? It's a palm sized optical sensors they have given. See. So they are hanging on their neck, and that can be measured. Okay, for PM 2.5. Handheld sampler. Palm sized optical sensor. Yeah. So question number 10 in 8th week. So in the same case study, which activity had highest exposure to fine particles? Traffic or cooking, market, workplace, classroom. We know cooking will give you lots of smoke and traffic will contribute to lots of fine particles. A is correct. Yes. Because in this case study, this is the result, right? So IST and ICS cooking will be higher. Here also they have mentioned traffic and cooking are identified as high exposure activities for PM 2.5. So for the 9th week, uh, according to the case study, indoor air quality in the UAE, what measures were adopted to monitor the indoor air quality in nursery buildings? What are the measures? Controlling the source of pollutant, improve ventilation, removing pollutant via purification, all the above. Yeah, all these are strategies they have given after the measurement because they have taken survey in all the nursery schools, right? And they have provided all the nursery schools are having pollution, indoor air pollution. So they have given some techniques to reduce, that is controlling the source of pollutant from closure of rooms and all. They have to control and improving the ventilation and removing pollution via purification. In some nurseries they have given as a accommodation measure. So all the above is correct. Yeah. 16 facility they have checked and this method, three methods are adapted: controlling the source of pollutant, improving ventilation, and removing pollution via purification. This is true or false? Um, Controlling the source of pollutants, improving ventilation, and removing pollution via purification. That's a control. It's a true. Okay, it's maybe incomplete. It's a method for keeping the indoor quality clean. Yeah, it's true. What is the primary substance responsible for ozone layer depletion? Ozone layer, we all know it should be a halogen. What are halogens? Chlorine, bromine, fluorine, iodine. So chlorofluorocarbon. Only if it is a carbon and H, there is no problem to the no problem. I can say it's a reduced problem to the ozone layer. So chlorofluorocarbons are emitted from refrigerants or any coolant what we are using. That's why nowadays all the refrigerants are changed to cleaner refrigerants. That's not having any halogens. So chlorofluorocarbons are the major responsible for ozone layer depletion, yeah, in the stratosphere. Which international treaty was established to address the ozone depletion? That also we have discussed in the treaties, right? Ozone depletion substances were banned in Montreal Protocol. So option C is correct. In Vienna Convention, 1985, paved a way for Montreal Protocol that concentration on ban of substances that deplete the ozone layer. In 1987, Montreal Protocol. Based on the Vienna Convention only, Montreal Protocol was established in Canada. So here you can see Montreal Protocol measures taken. Here you can see end production of halons in the developed countries. So that heals the ozone layer. What is the major cause of global warming? Particulate matter emission, accumulation of greenhouse gas, CO2 and CH4. This is a basic question. So deforestation in the tropical region, loss of biodiversity. Accumulation of greenhouse gases like CO2 and CH4. Yeah. That is the major contributor, 75% for greenhouse gases contributes to global warming. Which human activity is the largest contributor to methane emission? Human activity, that's anthropogenic activity. Industrial manufacturing, fossil fuel combustion, livestock farming and rice cultivation, urban infrastructure development. All are cause for methane emission, but which is major or largest contributor? We thought it's industry, but industry is not the major contributor. Livestock farming and rice cultivation. Think about the graph. See, methane is the second most anthropogenic greenhouse gas, but it is coming not only from industries. It's majorly coming from the enteric fermentation of the cattle or the livestock, and also from rice cultivation, that is paddy cultivation. Okay. Then seventh question: greenhouse gas act is the true or false? Act like a blanket wrapped around the Earth, trapping the outgoing long wave infrared radiation from the Earth's surface, and thus declining global atmospheric temperature. So all up to this is correct. The, above the earth layer, there is a greenhouse gas that will accumulate and whatever the heat energy coming from the sun, that is getting trapped here, and only less amount is reflected because greenhouse gases are there. And if it is no greenhouse gas, it will reflect from the earth surface fully. If there are greenhouse gas, that will trap the heat, so that increasing the global atmospheric temperature. So declining is wrong. So if it is trapped, it will increase the temperature of the earth surface. That's what global warming. So if it is increasing, that is true. If it is declining, then it is false. Okay, answer is false. That's called climate change. One of the impact is global warming. Okay, related to sustainable development goals, which is related to combat climate change. You have 17 SDGs, right? Which is related to climate change. SDG 13. Yeah. Please remember the SDG for climate change. You can remember all the 17 SDG goals or SD goals. Yeah. 13 relates to take urgent action to combat climate change and its impact. They have targets also. SDG 17 SDG, each SDG have some targets. 13.1 is strengthen resilience and adaptive capacity. 13.2 integrate climate change measures. 13.3 improve education awareness rising. These are all one of the awareness programs. So 13.3 it's related to 13.3 target and institutional capacity and climate change mitigation, because air pollution is the major source for climate change, right? Like methane and all. So this is coming under 13.3. So that Paris Agreement in 1996 parties they have signed in 2015. All the countries came into picture to combat climate change. Okay. Here, ninth question: which pollutant are responsible for formation of acid rain? That you all answered already. SOx and NOx. Yeah. Which is significant effect of acid rain on aquatic ecosystem? Because acid, if it falls on water, if it falls on the trees, it will affect all the leaves. If it falls on ocean or any water bodies, acid when you mix with water, what will happen? pH will reduce, so that leading to the death of aquatic organism. pH of water will be neutral, will be 7. It can handle up to 6.5, but when it's less than 4 or 5 like that, even fish can't adapt to less than 0.1. If it is 6.5, if it becomes 6.4 by adding acid, the fish can't resist. Even human can't resist a reduction of 0.1 pH. Okay, that's the problem. Which pollutant is, we are moving to 11th, 10th week. I hope it's the 10th week, right? No, sorry, we are in the 9th week. Yeah. Which pollutant is most commonly associated with the vehicular emission? Vehicle, as I mentioned, lead will come, but most commonly associated with vehicular emission, NOx. Yeah, this is 9th week. Sorry. So NOx will come from vehicle, that will react with the NOx will react with the VOC, and it will form ozone or PAN or smog. That is called smog, right? Peroxyacetyl nitrate. Smog is formed. During COVID, what happened? No vehicles were there, so NOx was not there. So slightly produced O3 got increased. When NOx directly reacts with the O3, that will give you O2 plus O, right? So there is no NO. There is NO, if it is there, that will take one of the O and become NO2, and O2 will be released. So ozone reduction, this is called ozone depletion. So if it is happening in the ground level, it's good. If it is happening in the stratosphere, it's wrong. Yeah. Engine exhaust. Which device is fitted in the vehicle to control air pollution from the tailpipe emission? Because from the vehicle, there are three emissions. One is from the tailpipe after combustion. Another one is from the engine while burning the combustion, whatever the uncombusted gas. Another one is in the fuel tank. Whatever the fuel that is volatile in nature, so directly it will emit into gas, liquid to gas volatilization. So these three are major emissions from the vehicles. So tailpipe is one of the major contributor. How to reduce the tailpipe emission? We can fit a catalytic converter, so that whatever the uncombusted gas that is coming out, that will be fully oxidized by the catalyst, like platinum catalyst or anything you can use as a catalytic converter. That will give you some fully combusted gas. Instead of CO2 will come out. So that is having less potential for health risk. Okay, like catalytic converter you can use here, ceramic or cerium based catalyst structure. What is the primary function of cyclone separator in air pollution control? Cyclone separator, what it happens, it will remove larger particulate matter from emission, right? Yes. Removes around 90% of 10 micrometer, 20 micrometer, 95% it will remove. So larger particle cyclone separators are good. What is the purpose of backhouse filters? Filters are having bags or cloth or a filter cloths that will remove fine particulate matter. These are all only for particulate matters. Venturi scrubbers, gravity settlers, backhouse filters, cyclone separators, electrostatic precipitator. All these five are for particulate matters. So for gases removal, gases pollutant, we have oxidation, condensation, adsorption, absorption, and microbial removal. Right? Yeah. Which air pollution control device is best suited for removing fine mist and liquid droplets? So if it is a liquid droplet, you can use wet scrubber, that will be useful. That's correct. In all this type of industries, they are using. Okay, sorry. But it's a true or false question. Biofiltration can be classified as a special type of absorption system that uses an irreversible process to control the gases contaminant. Because whatever the bioreaction, that is not reversible. Once it is getting accumulated, that will not be regained. So it's a irreversible process. So that's a true. You can see biofiltration. It's a irreversible process that contaminants is metabolized by the organism and carbon dioxide into water. So whenever there is a CH4, if you take or any carbon-based glucose or anything as a pollutant, if microorganism is reacting with oxygen, it will convert to CO2 and H2O. Metabolization, right? It will take energy and then it will release CO2 and H2O from the pollutant. The absorption process is classified as either physical or chemical. The type of force involved in the physical absorption. There are two absorption principles. What is absorption? What is absorption? Absorption is in the liquid when the pollutants are getting absorbed. It's absorption when it is getting absorbed on the solid particles on the surface. That is called the adsorption, right? So this principle adsorption is again classified into two. One is physical and one is chemical adsorption. So physical absorption, the force will be weak van der Waals force, and chemical reaction, it will be irreversible chemical reactions. Okay, so here they are asking what type of force is involved in the physical absorption. Weak van der Waals force. Yeah. Which of the following technique is adopted when the contaminant concentration is high enough to make a recovery? So we have gaseous pollutant removal techniques like absorption, adsorption, condensation, and oxygen. Why we have to condense the gas? Because whenever the gas is having more amount of pollutant that can be recovered and useful pollutant, it should not be emitted into the atmosphere. Then I can cool it at a very low temperature, and from the gas I can convert it to solid that can be compressed and that can be sold as a product. So condensation is good technique whenever there is a high concentration of pollutant which can have a potential economic value, then you can do condensation, right? Exclusively for the recovery of organic compound, like if it is a toluene industry or a benzene industry, after production, whatever the gas that is getting out, that may have lots of benzene. So I can also trap that benzene and I can sell with the industrial product, right? So moderate to high concentration that can be used at very low temperature, like convention, refrigeration condensers, like cryogenic condenser at minus 100 to minus 320 degree Fahrenheit also you can go and I can get. Which technology is used for control odor emissions from the wastewater treatment plant? For odors, only biofilters are good, not this type of physical methods. Biofilters are good for odor controls. Yeah. Gasoline fumes evaporating from the fuel tank and carburetor and enter directly into the atmosphere. This emission is called significantly reduced by, okay, from the carburetor. As I mentioned, from the vehicle, from the tailpipe, we can use catalytic converter. From the carburetor, that is the engine, I can use whatever the gasoline fumes evaporating, that is from the fuel tank. What I can use? Positive crankcase ventilation. That is the carburetor. They are asking the carburetor and enter directly into the atmosphere. This emissions are significantly. Okay. Earlier it was directly vented into the atmosphere. Now we have a evaporative control system that can be controlled within the carburetor and that will be sent into the combustion tank. So earlier it was vented into the atmosphere, but Nowadays, emissions are significantly reduced by sealing the fuel tank caps and evaporating control system. Yeah. So it's the 10th week. Yeah. So these are all questions. So we all know. I will just go through the formula. They have given the cyclone separator, size and effective turns, and temperature, velocity, cut diameter of the particle is 50%. They are asking what is the cut diameter. So what is the formula for cut diameter? 9 mu b by 2 pi b nt, and rho p minus rho. It's the density of the particle, density of the air, and nt is the number of turns happening in the cyclone separator. You all know it's coming. It's a circular motion, and 2 pi b is also known as the inlet velocity. B is the width of the entry. So here if it is entering, what is the width of the entry? So you all know, we can solve it. Here it's a backhouse problem where incoming velocity is given, um, filtering velocity is there, and flow is given each bag of 20 centimeter wide. Oh, it's not, it's the problem. 20 centimeter wide, let's say 20 centimeter dia. Then we can find how many bags. So it is a pi dl. You can find the area of one bag, and you know the area by total area by this formula. Uh, if you know meter cube per minute, and you know the meter per minute, you can get the meter square. Then you know pi dh, that you will get the meter square. Again, if you divide number of bags, you can get. No, 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 no. Earlier I had think that this was a b, so I have considered as a square. But in the solving, here you can they make this as a diameter. So if you take dia, it's correct. If you take as a width, then it will be wrong. I have considered as a square, 20 centimeter wide square. So if you have to take as a dia, because filter house will be always as a circular bag. Okay, so it's correct. It's correct. Okay. An electrostatic precipitator problem. Collection plate area they have given, gas flow rate they have given, collection efficiency. So all we know, migration velocity we can
So
use. Yeah, ma'am.
the question, data are correct.
Sorry.
The
Yeah,
data.
the data are correct. Actually, here you have to take d as diameter. Sorry, width as diameter, not the width. 20 centimeter if you take as dia, and by pi dl you can use. So you can find the number of bags.
Okay.
Okay. Earlier I was thinking with the square, so I am not getting 106. Okay. So if you think about electrostatic precipitator, we have only one formula, that is a efficiency formula based on angular velocity, area, and flow rate. Eta equal to 1 minus e power minus the omega a by q. So whatever you want, you can find. They are asking about the migration velocity, omega you can find with all the other data. Same formula you can use to find the collection efficiency with the other given data. Okay. The minimum size of the particle, that is the dia they are asking for a gravity settler. So gravity settler, we know the formula 18 v h mu by lg rho p minus rho power root of you can take. Okay. So all the other data are given. So you can find the dia of the particle, minimum size of the particle that can be settled in the gravity settler. And which of the following pollutant is not included in the revised National Ambient Air Quality Standard? Earlier it was 19th standard, and then it was revised to 2009. But still, which is not included? Ozone, benzene, arsenic, and cadmium. So the answer is cadmium was not there. So the old 1994 data only with the particulate matter and all. Now we have introduced other new parameters like ozone, arsenic, nickel, benzene, benzoyapyrene, that is BAP. All other, these are all included as new pollutants in the 2019 NOx standards. But still, cadmium is not a air pollutant included in 2009 NOx standards. Now, what is the annual permissible limit for PM 2.5 as per the WHO standards? It's not based on NOx standard. They're asking WHO standards in 2021, 5 microgram per meter cube. So 2005 and 2021 it was revised. So this also I have given in the points to remember, that also you can revise before your exams. So what is the primary goal of National Clean Air Program NAC in India? So to achieve 20 to 30% reduction of PM 2.5 and PM 10 level by 2024. That's the NCAP primary goal. Yeah. What is the focus of graded response action? GRAP. GRAP concentration only on the reduction of air pollution in national capital region. Yeah. So that was notified in 2007. Abate the air pollution in national capital regions and Delhi. Which Indian policy promotes the adoption of electrical vehicle? National Electrical Mobility Mission Plan, NEMMP. Okay. Yeah. So we are in the 11th week. So last week only we have discussed this. So I am just moving on fast. In 1991, which of the following protocol related to control of emission of VOCs? You all know which is for which all protocols. That also I will share today itself. So you can recollect once. So which is for VOC? Geneva Protocol. Geneva Protocol in 1991, they addressed the reduction of VOCs. That's the target. Primary goal of Paris Agreement, now only we have discussed it. Paris Agreement related to climate change, climate compact. So climate change is due to global warming. So limit the global temperature rise to well 2 degree above the pre-industrial level. That's what the Paris Agreement the primary goal. Reduce the temperature. Preferably 1.5 degree also, it's good. Yeah. Yeah, ma'am. Yeah, sir, you can ask question. Okay. Which treaty focus on reducing ozone layer depleting substances? No, Montreal Protocol only with the ozone depleting substances based on Vienna Convention. What was an unintentional consequences of improved air quality during lockdown? That also now only we have discussed in air quality. During lockdown, all pollutant got reduced, but only unintended consequences, a slight increase in the ground level ozone due to the vehicles are shut down. So now NO is not released. So if NO is released, it will react with the ozone and it will form NO2 and O2. So that is not happening. So the ozone level got increased in the ground level in some cities. To control the dust pollution at the construction site, which one of the mitigation measure is used? Because dust particles are very fine in the construction region, so I can add spray water. So that is called the fogging system. Spray water to settle down. What we are doing in the outside the house in the morning, just spray the water to reduce the emission of particulate matter from the ground. So that is fogging system. In same we are adapting in the construction sites. So which of the following mitigation strategies is focused to reduce the emission from enhanced the use of clean fuel in rural and urban regions? So one of the major scheme introduced in India is Pradhan Mantri Ujjwala Yojana, that is to improve the LPG usage in all the rural and urban areas, so that all the fossil fuel burnings are getting reduced, so that the air pollution is also getting reduced. Okay. Yeah, it's a cleaner fuel. Blending of dash percentage of methanol is in gasoline can bring the greenhouse gas emission by 20%. If you just add 15% of methanol, that itself reduces your greenhouse gas emission by 20%. Then think about 100% methanol as a fuel, because only CH4 will be there, right? Methanol, CH3OH, that is methanol, right? So there is no other compound. So if you are using methanol as a fuel, other petrol and all will have all other compounds, and everything will be there. But methanol will be purely C and H. That will reduce the greenhouse gas emission. What is finely divided carbon-rich porous substance that can be obtained from the crop stubble? Because instead of burning the crop stubble, that is the waste crops in the open region, I can do a process called pyrolysis at high temperature to produce a solid material that is very fine carbon-rich porous substance that can be used for adsorption. What is that called? Biochar. And last of cosmetics also they are using biochars. What is the size of PM10 particle? Less than 10 micrometer in diameter. 24 hours NOx standard for PM10. What is that? 60 or 80 or 100? 100. 60 is for annual. They are asking 24 hours standards. That is 100. You should, always annual will be, so 24 hours will be higher than the annual. Okay. In the 12th week, yeah. So I think this is the question you have to do today. So I am just revealing the answer. I hope you have done the question. So this is the last week, so I am just revealing the answers today. So PTFE refers to, that is used in the filter paper used for not the for particulate matter 10. It's for PM 2.5. What is called? Polytetrafluoroethylene. C is correct. Yeah, correct, ma'am. So that is used to draw the air through that filter in 2.5 samplers. And NOx standards for PM 2.5 in ecological area 24 hours. So second row, second column for PM 2.5. 40, 60, 80, 100. 60. Yeah, 60, 60. It was 100, 100 there. Here 60, 60. Usually 10 will be higher than 2.5, right? Yeah. So 66 microgram units you have to remember microgram per meter cube for PM. For 10 you can say it is microgram again. Yeah. Third question, the absorbing reagent potassium terachlorate mercurate is used in the sampling and analysis of, there are two absorbing solution, one is for SO2, one is for NO2. TCM is used for absorbing SO2 or NO2. SO2 is correct, yeah. SO2 we are using TCM. Yeah. Modified Jacob and Hessian method is for SO2 or NO2 analysis. Modified Jacob. Okay, so NO2 correct. For SO2, what is the method?
Weak and weak.
It's a Western geek method. Okay. In which type of sampling, the velocity and the direction of gas entering the sample nozzle and sample as that of the gas in the duct are same. So that's why we can get a representative sample. What is that called? Isokinetic sampling. That is, you can say velocity or you can use kinetic energy. So both will be same of the flue gas as well as the probe in the chimney. While taking the samples with the probe, whatever the gas that is emitting, the same velocity I have to take the sample. Then only it will get the representative sample. So isokinetic sampling is correct to get the representative sample. So which of the following method to measure the SO2? You have now only you said improved Western geek method. Modified Jacob is for NO2. Okay, both are absorption principle. PM is for gravitational principle, and also you can use spectrometry principle. Which pollutants are typically monitored using multi-gas monitor? Yesterday we had seen, right, a small multi-gas monitor that can measure CO, CO2, VOC, ozone. You can see TOC, carbon dioxide, carbon monoxide, ozone. Which of the following parameters measured using non-dispersive infrared spectrometer? So NDIR, you all know NDIR is used to measure carbon dioxide. Even carbon monoxide can also be measured, but that is a separate electrochemical method for CO. Like electrochemical sensors for CO and NDIR is for CO2. Yeah. Analysis particulate matter. What we can use? Spectrometers. If spectrometer is not given, gravimetric analysis is correct. If spectrometer is given, light scattering principle is correct. Okay, light scattering and laser diffraction. This is the method, right? We have same we have seen in the albedo effect. The minimum time interval, sorry, not the albedo, AOD, optical depth. What is that? Aerosol optical depth. The minimum time interval for monitoring particulate matter using spectrometer software is minimum is 6 seconds, maximum is 60 minutes, 1 hour. Okay. So in the spectrometer software, I'm saying. So 60 minutes is correct. So that's all about the actual 2025 Jan 2025 assignments. Hope you don't have any question related to the lecture material and problems. All the best for your examination. Thank you so much for joining the course. If you have any doubt hereafter, you can post it in the Google groups. That is also in the NPTEL SWAYAM portal. I think you all know about that. I'm just showing that. I have closed. Yeah, here. So here in the Google Groups question and answer, you can post your questions. I will answer all the questions by today night itself, whatever the leftover questions, and whatever the questions to the NPTEL team, they will answer soon. Okay. When will we get the hall ticket? I don't know. So NPTEL team will answer the question. Okay. So thank you so much for joining. I hope you all enjoyed this problem solving session. If you have any doubt, you can reach me out to this email ID or through this phone number also if you want to connect. Thank you so much. If you want any future collaboration in this regards, you are most welcome to this, and you can write to me at any time. As I mentioned, I am working on solid waste management in landfill mining. So thank you so much. Hope you enjoyed. If you have any doubt, you can unmute and you can ask, or you post it to the chat box. I will be here for next 5 minutes. Otherwise, you can leave the meet. Thank you all. Thank you for joining. All the best for your examinations. Thank you all. You can leave the meet now if you don't have any question. If you have any other general question also, you can ask. Okay. Hope you don't have any more question. I'll end the meet. Thank you all. Thank you.